Let them catch up later. I'll provide some recorded videos if possible. Okay. Yesterday we discussed about a problem involving principal stress, right? We discussed about principal stresses and principal planes. Also, we discussed about various loading condition and finding how to find the principal stresses, that is a normal and tangential stress over those systems. Axial loading condition, bending, torsional, axial and bending combination, then axial and torsional combination loading condition, bending and torsion combination, and also system where the three loads act at the same time, that is axial loading, that is tensile or axial, you can say. Here in this case, uh, bending, that is due to load P1, and also torsion. These three loads combined and acting over this cantilever beam also we discussed. We discussed about a system where uh, we saw only axial and tangential, principal stress. We discussed about shear and normal stresses acting member. In this machine member we discussed. Similarly, today we will discuss about element where torsion and bending and also an axial loading is applied. Okay. If you see, today we will discuss this problem. In this problem, if you see, a circular shaft of 30 millimeter diameter is subjected to an axial load, bending moment and twisting moment. Here in this system, all the three loading conditions are there. If you see, here bending is acting. Here this 12 kilonewton of axial load, that is in this case it is tensile loading condition. Tensile load is acting, and also a torsional twisting moment, that is also of 120 Newton meter is acting on this cantilever beam fixed at one end. If you consider this system, we have to find what will be the maximum principal stress and minimum principal stress, and also maximum shear stress at points A and B. If bending is acting means there will be 2 points we have to consider, because if bending is not acting means only overall body will be subjected, overall condition can be assumed. But in case of bending loading, we have to consider one point where tensile load will be acting and another point where compressive load will be acting. So we have to consider these 2 points. Bending is acting means they will ask for 2 different points. For these 2 different points we will be calculating the principal stresses. Okay. If you see, they have given the problem for a cantilever beam, or in this case circular shaft. They have given it circular shaft which is fixed at one end, and load is acting normal to this face at this end of the shaft. Axial load is acting, and here bending is acting, and torsion is also acting. The length of the circular shaft is given as 100 mm. Circular shaft diameter is also given in the problem. So first you have to write down the given data. Already we know what are all the notations we have to use. For diameter D, for length L, and also axial load. If it is a load means we have to use notation of P. Load we have to use PA. Suffix A denotes axial load, 12 kilonewton. Then also similarly bending load PB. Bending denotes is denoted by B letter, 5 kilonewton. Then we have to denote a twisting moment as MT, M suffix T. These are all the notations which we use by referring data book, because in data book they always denote the notations in this way only. Here if you see MT is given for MB is given for bending, and also if you see another page here, MT is given for torsion. So we have to use only MT for torsion load condition, that is twisting moment. We have to calculate the principal stresses at point A and point B. Let's see how to solve this problem. First we have to find maximum principal stress and minimum principal stress and maximum shear stress at both the points, point A and point B. First let's find out direct stress, which is caused by this direct axial load, 12 kilonewton. If you see here, this direct stress formula you already know, load by area. In this case, since it is a circular shaft, the area will be pi by 4 d square. You have to apply the values, diameter of 30 mm, you have to use it here. Similarly, load PA, you can take it as 12 kilonewton, and also you can calculate the formula, area value is coming around pi by 4 into 30 square, it will give you in terms of mm square. Also you have to considering the unit system. In this problem we are using millimeter. Here they have given shaft and length in terms of millimeters only. In case of twisting moment also, we have to convert it to millimeter. Actually there is no need for you to convert it to all to millimeter. If you want, you can convert it to meter also, but since only one component has to be converted to millimeter, you convert it to millimeter. It's better to convert it to Newton millimeter for twisting moment or torque in this case. If you see this problem, first after calculating the direct stress, we have to calculate bending stress. Three stresses we have to calculate: direct stress, bending stress, and also here due to this moment you will be having some shear stress. Okay, torsion will cause shear stress, so we have to calculate these three stresses. First calculation of direct stress. For that we used the formula of load by area. First note down this slide first. Take your note and note it down. You all are noting it down, right, in your note, because if you note it down today means it will help for you for revision and all. Note it down, pa. Note down the content from this slide. Section 2. I already explained you what are all the various types of loads that will be acting on any design member. In this case, circular shaft. Here, three loads are acting in a combined manner. That too, in the particular beam. In this case, a circular shaft. Axial load, bending, and torsion. Everybody note down this slide. You have written the content from this slide. Students, please interact with me. Then only I will be able to understand what you are saying. Okay, write it down. Write it down. Okay. Write it down, because we will be asking you to submit your notes in the form of scanned soft copy in Google Classroom soon. After completion of Unit 1, you have to submit your notes material also in Google Classroom. You have to submit it as an assignment. Your complete notes that you have noted down after during this 2 weeks time, you have to submit it in Google Classroom soon. It will be one of the assignment for you. You have to submit your classwork. You have to scan it using cam scanner or any other software. Then you can submit it. Even if it's possible, you can just upload it as a compressed image file content if possible, or you can convert it to PDF also. So I recommend everyone to write it down. Write down your subject material in your classwork note. Shall we go to the next slide?
1 minute, sir.
Okay, bro. Okay.
Yes, sir. Okay, sir. Update us.
Okay. Um, let's go to the next slide. If you see in this problem, we have to calculate axial load. Load causing stress, that is direct stress in this case, caused by 12 kilonewton. Also, you have to calculate bending stress, which will be generated due to this 5 kilonewton bending load, and also torsion. This will cause some shear stress. You have to calculate that shear stress also. Let's go to the next slide. Here we have calculated direct stress, which is nothing but load by area, that is caused due to the axial load of 12 kilonewton. Uh, no, you have noted down the diagram, right? You check in that axial load is 12 kilonewton. The area which we have calculated is 706.85 millimeter square. Substituting these values, you will get 16.97 Newton per mm square. You see, direct stress, after calculation of direct stress, you have to calculate bending stress, that is caused due to bending load. Here, if you see this formula, you can take it from the data book itself. For circular member, there will be a separate formula. Well, this is our data book reference. I will open it in PDF. Here, if you see, this formula is nothing but the formula which we have used right now. Here, if you see 32 MB by pi d cube, instead of pi d cube, they have given it in terms of d naught and di, because this system is a hollow shaft condition. This formula is somewhat similar. Bending stress value will be 32 MB divided by pi d cube. In this case, instead of d naught and di, they have combined it into d cube. This formula you have already studied. You have already studied in your strength of materials, I think. This value, this formula, you need not memorize much. Even if you forgot, you can refer the data book and note it down. For calculation of MB also, load uh, into length, perpendicular distance. This also formula you need not memorize. You will be having the formula in this page. Simply supported, not simply supported, cantilever beam. Here, if you see this formula, M is nothing but moment is nothing but P into L. This formula is used. Here in this case, they have used a negative sign since for this problem. Here, load into length. This formula is applied here. MB equal to load into length. These formulas you need not memorize. I again repeat it. You need not memorize these formulas. It will be available in your data book, but you have to know and remember how to find out these formulas. It will be available in few pages in data book. You have to just familiarize yourself with data book first. It will be easy for you while solving the problem. Bending moment, after calculating bending moment, you can substitute that in this stress formula, 32 MB by pi d cube. After substituting that, you can calculate the bending stress also. After that, only shear stress is the one which is pending, which is there, which we have to find out. Shear stress formula is also, you already know, This formula is nothing but torque is equal to pi by 16 tau d cube is there, right? That formula is the tau is nothing but shear stress. The tau value we can calculate using this formula. It is that formula can be transformed to this. You noted down this slide. Next, you have to calculate at stresses at A and B. If you see for stress at A in this slide, if you see here at A, tension, due to tension caused by this bending load, you have to add this sigma B, bending stress. This bending stress has to be added with axial to find out the principal normal stress at the point A, and also point B you have to subtract this bending stress caused due to bending load. If you see here, sigma x, that is normal stress, principal stress induced at that particular point, sorry, not principal stress, normal stress caused at that point, sigma x is equal to the direct stress with bending. These two has to be added. These two are normal stresses acting at that point along the x-axis direction. Along the y-axis direction, nothing will be acting, because y-axis means it's opposite direction. Nothing is acting in that direction. Only along right side towards A, from A to the right side, only these two loads are acting. That is direct stress and bending stress. After noting this half, note down this half also. Okay, you completed this, huh? When a member is subjected to bending stress and direct stress, then the combined stress that is acting is nothing but direct and bending stress added together. At point A, sigma B will be positive because tensile stress is induced at that point on the above surface of that circular shaft at point A. Similarly, at point B, what will be acting? Compressive stress will be acting. It will be minus sigma B. You have to use minus sigma B. At point A, what will be the shear stress? Maximum principal stress at A. If you consider point A, maximum principal stress is nothing but this formula. This formula also you have in data book. We calculated the direct stress, axial stress. If you see this, this is nothing but sigma x and sigma y are components of that stress. These stresses, if you see resultant value along x-axis, normal stress. This is the sigma x, normal stress acting along x-axis over at point A. If you consider this formula, sigma x and sigma y, for sigma y it is 0, sigma x we know already. Shear stress value, what will be the shear stress at that point? Same, 22.63 will be the shear stress which will be acting at this at point. It will cause the stresses will be caused due to these three loads. So we used sigma d and sigma b for calculation of principal stress, sorry, normal stress, and also shear stress we calculated. Those formulas you have to substitute in this formula, because sigma x, sigma y and tau xy we have calculated these three. You can calculate at point A. If you consider point A, what will be the principal stress? Principal stress we already know, three formulas are there. First of all, you have to remember what is meant by principal stress and normal stress. Normal stress is the stress component which is acting at that surface normally. Principal stress will be somewhat the maximum value of the normal component acting on the whole object, whole element. Okay, this formula is also available in PhD data book 7.2. You have to refer that the page. Note down this. We yesterday itself we discussed about this formula. Sigma 1. Similarly, sigma 2. For sigma 2, you have to use negative sign. It will give you the minimum principal stress. Then we have to calculate shear stress at point A. You can note down this formula and calculate them. This formula will be available in PSG data book. Sigma x we already calculated, sigma y also we already calculated. Sigma x y we calculated means those formulas you can use here, those values. Similarly, tau xy also you can use. These are all the maximum and minimum stresses acting at that particular point. Okay, note on this also. Tau max also, this formula is available in data book. We yesterday itself I have shown it. I will show it today also. 7.2 here. This formula, sigma 1 comma 2 is given, right? For sigma 1 you have to use plus sign, sigma 2 you have to use minus sign. This will give you the principal stresses acting at that particular point. This will tau will give you the shear stress, maximum shear stress at that point. So you can use these two formulas and apply them to find out the values. Why do we need to calculate the maximum principal stresses and maximum shear stress value at that part, at any point? Can anybody explain why do we need to calculate the value of the principal stress? Why do we need to calculate the principal stress?
To reduce the failure, sir.
Okay, correct. To avoid failure, because the principal stress and shear stress acting at the points will give you the maximum stress that will be acting on that particular whole object. If you find out that particular values, it will help you to avoid failure in that object. You can design the particular element in such a way that the stress bearing capacity of that particular element will be more than the principal stress. Okay, so only we have to calculate the principal stresses. This will help you in calculating the designing a particular member, any member. It can be a shaft or it can be a bolt or whatever it is. Similarly, you have to find out stress at point B. At point B, if you consider the normal stress due to sigma x and sigma B, that is bending and direct stress, will cause some component of normal stress of sigma x value. If you consider this, you have to use negative sign for bending, because compressive stress is induced at the point B, that too due to the bending. So sigma x value will be sigma d minus of sigma b. In case of point A, you used plus sigma b. Here for point B, you have to use negative sign for bending stress, because it is a compressive form. If you see here, sigma x value comes in negative, then what is the meaning of that? It is somewhat compressive in nature. More compression is dominated, so it will undergo some compression compressive transformation at that particular point. Similarly, you can calculate maximum principal stress at point B also. Same procedure, but instead of using the values that you already found out for point A, you have to use this sigma x for point B. For point B, this value of minus 171.65 you have to use for sigma x. And also for shear stress, it is same. Shear stress at acting at point B, you have to use tau xy. That will be same. It will not change for any component, any point. The torsion effect will be uniformly distributed at point A and point B. It will be same at point A and point B also. It will be same. Only due to bending, the stresses will vary at point A and point B. Note down this also. After writing this half, you have to write down the second half that is available in your right side. Note down the stress at point B values also. If you consider principal stress, maximum principal stress at point B will be sigma 1. Here only one difference will be there. Sigma x value will be negative. Here this value you have to use. Other than that, everything is same. Okay. Instead of 205.59, you will be having some value of 171. I would recommend you to use calculator. If possible, use some formula calculation method to just change the values, or you can see the history in your calculator, right? Use that history and change the value of 205.59 into minus 171.65. It will be easy for you to calculate. Okay. Similarly, for if you consider for minimum principal stress, sigma x value will be varying. Shall we go to the next slide? You noted down this slide. Huh?
Except.
Okay, I will go to move to next slide. Next slide. For minimum principal stress, sigma y
So one minute. Next
and
slide
sigma
wings.
x. Pardon, ba? You want to go to next slide, or this slide is okay? You want to, if you are
This
missing
high
any,
sir.
enapa?
இந்த
Not
ஸ்லைடு
clearly
கொஞ்ச
audible.
நேரம் இருக்கு சார்.
Okay, okay. You want to write down something from this slide? Huh? Okay. If you see sigma y is 0 for both point A and point B. Okay. Shall we go to the next slide? Anyone writing in this slide? I will go to the next slide. Okay. If you see in next slide, we calculated the minimum principal stress at point B. The only difference is for minimum principal stress means you have to use negative sign here, and also for point B you will be having value of sigma x as minus 171.65. Same formula you have to apply for similarly for which you use for point A. Same formula you have to use. Now if you consider maximum shear stress at point B, what will be changed? The same formula. The same formula which you used for point A. The same formula for tau max and sigma 2. Same you have to use. But only the difference is sigma x value will be varying. Almost similar methodology for point A and point B. Okay. You can note down the values also. In our question, they have asked for us to calculate sigma 1, sigma 2 and tau max for point A and point B. We have calculated that. This concludes this problem. Is there any doubt regarding this problem? Note down this page also. Is my slide visible?
Yes, sir.
Yes, sir.
Okay. Note down this slide. மணி சார் டிசைன் டேட்டா புக் அங்க இருக்கும் கொஞ்சம் எடுத்துட்டு வாங்க ஒரே ஒரு எதுக்கா அனிமேஷன் சாரி நானே ஒரு 10 minutes வீடியோ அதுதான் பார்க்குறேன் இன்னைக்கும் ஒன்று ட்ரை பண்ணேன் completed this problem okay mute பண்ணிடுங்க this only thanks you completed
Yes, sir.
okay if you see then are you able to view my webcam
Yes, sir. Yes, sir.
you see this is our design data book. This book only you have to use for exam. It will be around some more than 900 or 1000 pages will be there. Okay, this will be allowed for you to use during your university exam also. Okay, you can use this design data book. I have shared you the soft copy through my window. This is the data book I already shown you. You have to buy it or you can get it from your seniors, because if you have this data book beside you, it will be easy for us to communicate effectively. Okay, what are the pages that I am showing and asking you to view, you can view it in the data book. It will be better if you have this data book with you. Okay, let's go back to our problem. You completed this problem, huh? Is anyone writing this problem? Shall we go to the next content? Next slide.
slide மட்டும்
Napa? Okay, wait.
அந்த
Sorry.
slide மட்டும்
Slide share பண்ணல. Okay. I haven't shared the slide, right? Oh, I am presenting only. Slide is visible. Okay. Is my slide visible for you now?
yes
Sir, visible, sir.
Okay. Okay. You completed this problem, huh? Shall we go to the next slide?
sir wait sir one sec sir
Okay. Okay, I'll wait for 2 minutes. You have any doubt regarding this problem? You can ask.
ரெகுலேஷன் ஆகுதுல
Anybody still writing this problem? Completed, huh?
Completed, sir.
Yes, sir.
Okay, bro. If you see the next problem, you can write it, note it down fast, because we have some around 20 minutes, I think. We can complete this problem also soon. If you consider this problem, it is a design member. This member, can you identify what is this? In question itself we have given it. It's a crank. This handle you have to, it will be causing some bending or torsion acting on that. We have to rotate this crank. The dimensions of overhang crank are shown in this figure. The force P acting at the crank pin. Here the crank pin at the pin, there will be a load of this crank pin is the protruded element which is there here. At this crank pin, the load of P is acting. That too, the value of load is given as 2 kilonewton. Load P equal to 2 kilonewton. We have to determine the maximum stresses at the section XX here at this cross section. At this point, what will be the maximum stress experienced due to this load? What all the stress which will be caused at this point at this section XX by this load P? That too, this pin is at a distance of 400 mm. What does this imply? This load acting at a particular distance. What is the implication from this? This load is acting at this point at a distance of 400 mm. This resembles what example? Loading condition. What sort of loading condition is acting at this point? Will be caused at this point due to this load. Simultaneously, you note down the question and given data. The distance that is acting the load is acting from this point is at a distance of 80, 20 plus 40. That will give you 140 mm. This is the horizontal distance. This will be the vertical distance which they have given. This will give you the radius of rotation. This will cause some rotation, right? At this point, if the load is acting in this manner, it will cause some rotation. This causes what sort of load condition? Radius of rotation is given, means what sort of load you have to consider? Torsion or bending moment? Rotation.
Bending, sir.
Bending.
Torsional, sir.
Torsional, okay, right. Torsional load condition will be there because if you remember you remember that formula, right? Sorry, bending will be acting. One second. Bending will be acting. This load, it will cause some moment at that point. Torsion only, correct. Torsional load will be acting due to that moment at that load. Torsion will be there. Let's go to the diagram. Here, the load acting at this point, it is in this direction, right? It will cause the crank to rotate. So it will cause some torsion load. Torsion only will be acting. Then the load is acting on this pin element, right? It will cause some bending also. It will cause some bending also at the distance at which the bending takes place. Will be this value will be the bending distance. You have to, if you see the problem, it will you will understand. The bending cost will be, the distance will be, you have to consider 140. You note down the given data. I will show the display the diagram again. You first note down this slide first. We'll solve the problem soon. Note down the slide first.
சார் இந்த ப்ராப்ளம்ஸ்லாம் எந்த டெக்ஸ்ட் புக்ல இருந்து சார் எடுக்கிறீங்க?
ப்ராப்ளம் பாத்தீங்கன்னா இந்த புக் எடுத்துக்கோங்க, பாஸ்கர் பை டிசைன் ஆஃப் மெஷர்மெண்ட்ஸ் பை பாஸ்கர், ஏஆர்எஸ்.
ஓகே சார்,
ஏஆர்எஸ் பப்ளிகேஷன் தான்.
ஓகே சார்.
பட் அந்த புக் வந்து பாத்தீங்கன்னா சாஃப்ட் காப்பி கிடைக்காது, ஸ்கேன் பண்ணி தான் போட்டாங்க.
சார் அந்த ஸ்கேன் காப்பி கொஞ்சம் அனுப்ப முடியுமா சார்?
டேட்டா புக் இருக்குல சார்.
என்னப்பா?
டிசைன் ஆஃப் டேட்டா புக். டேட்டா புக். அது என்ன மாத்துது சார்?
அது வந்து டேட்டா புக் பாத்தீங்கன்னா பிஎஸ்ஜி டேட்டா புக் சொல்லுவாங்கப்பா. பிஎஸ்ஜி காலேஜ் இருக்கு இல்லையா, பிஎஸ்ஜி காலேஜ் ஆஃப் டெக்னாலஜி இஸ் தேர் ரைட், கோயம்புத்தூர்ல. அந்த காலேஜ் பப்ளிகேஷன். டிசைன் டேட்டா புக்னாலே இப்போதைக்கு அண்ணா யூனிவர்சிட்டி அண்ட் பாண்டிச்சேரி யூனிவர்சிட்டி ஃபாலோயிங் பாத்தீங்கன்னா டிசைன் டேட்டா புக் பை பிஎஸ்ஜி டெக்னாலஜி, பிஎஸ்ஜி காலேஜ் ஆஃப் டெக்னாலஜி.
Okay sir.
I will show the data book display. It will display some data regarding publisher. You can see this. Here if you see, compiled by Faculty of Mechanical Engineering, PSG College of Technology. Kalai Kadir Achagam. This data book, it will be available in old bookshop also. You can buy it from there also. In Kitab or Jumbo bookshop also you can buy it. It will be there. Okay. If possible, get it from your seniors. They will not.
சார் அந்த RS பாஸ்கருடைய புக் சாஃப்ட் காப்பி அனுப்பிச்சு விட முடியுமா சார்?
அது நான் புக் ஃபுல்லாலாம் எதுவும் தர முடியாதுப்பா. இதுதான் போட்டோ எடுத்து தான் நான் இந்த தேவையான ப்ராப்ளம்ஸ் மட்டும் தான் போட்டிருக்கேன்.
ஓகே சார்.
Okay, sir.
I will share another book which is also same publisher. Somewhat similar problems will be there. I will share it soon. First, you note down the content first. I will share it during the mid of our semester. I will share it. Okay. You note down this slide. Shall we go to the next slide?
Yes, sir.
Yes, sir.
If you consider this problem, you will be the element crank will be experiencing two types of loading condition. One will be caused due to bending, that is due to this crank hanging over here. This hanging will cause, at this point it will be hanging, right? So it will cause some bending at this section XX, and also another load will be caused in form of torsion due to the rotation of this crank pin. It will cause some torsion at this section. This XX is nothing but this hatched area. This is the side view of this diagram. This is the crank. The side view will be like this. Here this hatched area is the section XX. For this area only we are calculating the maximum stress at this section. If you see, we have to calculate maximum principal stress. In this problem, they have asked only for us to calculate only maximum stresses. That means maximum principal stress and maximum shear stress only, not minimum principal stress. If you see minimum principal stress, what we have to calculate, you already know, right? Negative sign in that formula for sigma 1. We can avoid that minimum principal stress, that is sigma 2, we can avoid. They have asked only to calculate sigma 1 and tau max, that is maximum principal stress and maximum shear stress. Here two types of stresses are acting. That's what this sentence is conveying. No direct stress is there because there is no direct loading condition in this problem. Only bending is caused and also one torsion is there. No direct stress, that is no tensile or a compressive stress is acting in this problem. Only the stresses are bending and torsion. You see, bending will cause bending stress, torsion will cause some shear stress, that too torsional shear stress. If you see in this problem, you can use this formulas. Sigma b you already know, bending stress formula, similar formula which you have used already, 32 by pi dq into mb. mb we have to calculate bending moment caused due to the bending load p, that is p into l. L we already know, L is nothing but the total value of this distance, 80 plus 20 plus 40, distance between the load acting point, that is point P, and this section XX. That will give you your perpendicular distance. If you consider the bending moment, load into perpendicular distance, this formula, if you see, P into L. Load they have given it as 2 kilonewton. Similarly, L is given as 140 millimeter. You can calculate the bending moment, 280 into 10 power 3 Newton millimeter. You can substitute that bending moment value here and you can calculate the bending stress. Why haven't we calculated this bending stress? In this problem, do we have to calculate maximum principal stress at 2 points or only 1 point? What they have asked, they have asked for us to calculate on the overall cross sectional area, that too for area of xx. Okay, you need not calculate tensile form and compressive form of loading conditions. You have to consider only tensile. In this case, positive sign can be used for bending stress calculation. After calculating bending stress sigma b, you can go for calculation of shear stress, that too is caused by torsion. Okay, if you consider torsion shear stress, the moment cost will be equal to twisting moment will be equal to load into perpendicular distance. For this, in this case, this distance has to be radius of gyration, sorry, radius of rotation. This distance will be the distance that you have to consider for calculation of turning moment. Here mt, load is p, and r we have to use 400, that is the radius of rotation. If you substitute for this also, you can calculate the shear stress value. Here they have directly calculated the sigma x. Sigma x is nothing but the normal stress. That value, you know, direct stress is there, right, in this problem. So you can directly take the bending stress sigma x for sigma x, and sigma y will be 0. Like other problems, sigma y will always be a 0 for this problem also. In some conditions, sigma y will be there. We will see in future such problems. Note down this problem, this slide. Let's move to the next slide once you completed this.
Yes,
slide.
sir.
For shear stress, you can calculate using this twisting moment that you calculated here, mt. Substitute it here. This will give you the shear stress. We have calculated only shear stress and normal stresses. We have to calculate principal stress and maximum shear stress. For that, the formula is different. It will be somewhat resultant from these two stresses. Okay, completed this slide. Is anyone writing?
Completed, sir.
Okay, I will move to the next slide. For principal
Yes,
stress,
sir.
the same formula which we have already used for other problem. Only one change is only we have to calculate only for sigma 1. No need to calculate sigma 2. They have asked only maximum stress. Maximum stress means always sigma 1, and also maximum shear stress. Maximum principal stress and maximum shear stress we have to calculate. Sigma 1 value will be half of sigma x plus sigma y plus root of sigma x minus sigma y square plus 4 tau x square xy square. Those values we have to substitute. In case of sigma x, we already calculated. Sigma x value is 105.63. It is nothing but our direct bending. It is nothing but our bending stress alone. No direct stress is acting in this component. So directly we can use the bending stress value. Sigma b is equal to sigma x 105.63. Sigma y is always 0 in such problems. You need not give any values for the sigma y. Tau xy we already calculated. So this will give you the maximum principal stress. Sigma 1 212.69 Newton per mm square. Similarly, maximum shear stress also you can calculate using the formula available in your data book. This page number PSG data book reference, you have to note it down in everything. In all the problem you have to write this reference. It will differ for each and every problem. This data page number value will change. This 7.2 is nothing but this value 7.2. This is the 7.2. Here you see the page number value is 7.2. You have to note it in your problem also. Even during exam also you have to give the reference that you have referred in page number 7.2, like this. From page number 7.2 from PSG data book. That's what you have to write during exam also. You completed this problem, huh?
Yes,
Same,
sir.
Yes, sir.
similar to the previous problem. This problem, only one change is there. There is no direct stress acting in this problem. Here in this crank, there is no direct stress given. Only stress caused due to this load will be in form of torsion and bending. Okay. This is what they have asked. Maximum principal stress. Already it's repeated. Okay. You completed means we can discuss about the next topic. Actually, we can discuss this topic in our next class, I think. We still have some 10 minutes, right?
Sir, and the types of loads acting on a beam on the slide நேத்து போட்டீங்களா சார், அதுக்கு போறீங்களா ஒரு நிமிஷம்?
அது மறுபடியும் நோட் பண்றீங்களா? Okay, I will show it. This what you asked, right?
Yes sir.
Okay. ஏதாவது டவுட் இருந்தா கேளுங்க. இதுல கொஞ்சம் கன்ஃபியூஸ் ஆகுற மாதிரியே இருக்கும். பிரின்சிபல் ஸ்ட்ரெஸ், நார்மல் ஸ்ட்ரெஸ்னா என்னன்றது. நார்மல் ஸ்ட்ரெஸ்னா ஜஸ்ட் அந்த பர்டிகுலர் ஏரியால ஆக்ட் ஆகுற நார்மல் ஸ்ட்ரெஸ், அந்த ஃபேஸ்ல சர்ஃபேஸ்ல ஏதாவது ஒரு ஸ்ட்ரெஸ் தான் ஆக்ட் ஆகும். அதே பிரின்சிபல் ஸ்ட்ரெஸ்ன்றது பாத்தீங்கன்னா அந்த பிரின்சிபல் நார்மல் ஸ்ட்ரெஸ், ஷியர் ஸ்ட்ரெஸ் எல்லாமே சேர்த்து ரிசல்டண்டா ஏதாவது ஒரு பாயிண்ட்ல மேக்ஸிமம் நார்மல் ஸ்ட்ரெஸ் ஆக்ட் ஆகும். அதுதான் பிரின்சிபல் ஸ்ட்ரெஸ். தட் டூ பாத்தீங்கன்னா மேக்ஸிமம் இருக்கும் ஒன்று, மினிமம் ஒன்று இருக்கும். தட் இஸ் வாட் சிக்மா 1 அண்ட் சிக்மா 2. சிமிலர்லி ஷியர் ஸ்ட்ரெஸ்ஸும் பாத்தீங்கன்னா வெறும் ஷியர் ஸ்ட்ரெஸ் ஒன்று இருக்கு. அது இல்லாம மேக்ஸிமம் ஷியர் ஸ்ட்ரெஸ்ன்றது ஏதாவது ஒரு பாயிண்ட்ல இந்த நார்மல் ஸ்ட்ரெஸ் ஆல்சோ வில் காஸ் சம் ஷியர். புரியுதா? நார்மல் ஸ்ட்ரெஸ் எதாவது ஆக்ட் ஆனாலும் இட் வில் காஸ் சம் ஷியர் அட் எனி பாயிண்ட். Due to that, you will be getting some maximum shear stress. That's what we have to calculate for maximum shear stress and maximum principal stress. The note down பண்றியமா இந்த slide. If any
Yes, sir.
also if you want, you can note this down if you missed it yesterday.
Sir, next slide sir.
Next slide. Okay. I will do one thing, but I will share it in PDF format. Today I will share it. Okay.
Okay sir.
I will share this content in PDF format today. You can refer it in your Google Classroom. Okay. I will upload it in Google Classroom. You can use it. Because it will take more time if you refer it during class time. Also, we have to complete this unit by next week, because around so far how many hours? 4 hours completed, right? Around 4 hours we have completed. 4 class hours. Okay, we still have some 5 minutes, right? Show you any technical videos if possible. For 5 minutes we will see this video.
How does a chainsaw?
If audio will not be there, I think it will be some what that issue is not rectified still. Check for it. You just verify whether you are able to hear my voice first.
Hard wood like a hot knife through butter. What allows a jukebox to play thousands of songs without getting jammed? And what makes the fishing reel tough enough to pull in the big one? To To answer these mysteries, we dive deep inside these extraordinary machines to reveal the secrets of how they work. The chainsaw. How does this machine cut through hard woods like oak at an inch a second without doing the same to the operator?
Are you able to hear the audio?
Hundreds of moving parts work together. A lightweight piston drives a toughened crankshaft. This powers a 3-row chain that runs at a colossal 70 miles an hour. On the outside rows, 33 razor-sharp cutting teeth can rip through even the toughest hardwood. The key to the chainsaw's power isn't the teeth, it's the flat piece of metal that the chain runs around. It's called a guide bar. It has to be strong enough to support a fast-moving chain, but light enough to hold at arm's length all day long.
ஏதாவது ஒரு பாயிண்ட்ல ஆடியோ கேட்டுச்சப்பா? கேட்கல எதுவும்? ஆடியோ கேட்டுச்சு? எதுவுமே ஆடியோ வரல இல்லையா வீடியோ ப்ளே பண்ணும்போது?
No sir, கேக்கல.
No sir.
இந்த வீடியோவோட ஆடியோ எதுவும் வரல. ஓகே. I was trying to rectify something, it's not working. Okay. Still I will show the video.
To save weight, workers at this Virginia
video.
Beach factory build this guide bar in a very special way. It's hollow.
What we're doing here is we're taking the parts that we stamped out, outer plate and inner plate, and putting them together to basically make the guide bar.
Brian heads a team of engineers that run the massive robotic guide bar production line. It's one small part of a 2 million square foot factory that produces 4 million units a year.
It's such complicated equipment.
Around 40 lakh components are manufactured in a year. This chainsaw in that particular factory, they are manufacturing around 40 lakhs.
This is the
4
most
million
automated system.
components are manufactured.
As long as they keep it running, I'm a happy camper.
This robot takes 2 solid pieces of metal and stacks them with a hollow section in the middle. It then delivers the bar to a giant welder. 18,000 volts of electricity fuse the metal together. The hollow core makes this metal sandwich much lighter than a solid bar, but just as strong.
It's very rigid. Once it's welded, you end up with a very strong end result.
At the tip of the guide bar, a cog that spins on bearings.
If you see this in this video, there will be so many components that is assembled. Each and every component will be designed accordingly, such that it will not fail. Okay.
Helps the chain run smoothly. All it needs now is a chain.
Even a single cutter used in this component will be designed perfectly.
The design of the chain
But
is the secret to this machine.
if a smaller component fails, it will cause the failure of that particular machine itself. So each and every element designed in this
3 separate rows of
machine
toughened
will be
links make up the chain. At the base of the
carefully
central
designed.
row, long blunt hooks slot into the guide bar for maximum stability. A toughened sprocket delivers power to the chain from the
Chain
engine.
drive run by the sprocket. The blades
Run
available,
along the outside
each and
rows.
everything has to be designed perfectly
Chrome-plated,
in this
hardened
machine.
steel cutting teeth
Cutter
deliver 500 cuts a second. A chain this powerful needs one tough engine. The secret to the engine's resilience lies in the way it's put together. Giant robotic lathes cut the engine's components out of solid metal.
Engine.
But normal steel isn't strong enough for the hardest working part of the engine, the crankshaft.
This is the crankshaft.
This converts the up and down movement of the piston into the spinning motion of the drive shaft. Every time the piston fires, it puts the crankshaft under huge stress.
How many cylinders there? Can anybody explain? Speak and can anybody tell how many cylinders are there in this engine?
Moves inside the chainsaw and this type of matter. This is one of the most important parts inside the chainsaw.
Keith heats the crankshafts inside a giant furnace.
We already discussed about heat treatment, right? Heat treatment is one of the important concept in design of machine elements also. It will enhance few properties. It will enhance hardness. This is the heat treatment area.
Do it right, and they come out harder and stronger. Get it wrong, and the whole batch is ruined. In this US factory, Keith's about to make the toughest part of the chainsaw, the crankshaft, even tougher. By putting the whole batch in a red-hot furnace.
Hardware is brittle, so it's a very detailed science to get the part just right. We're opening up the furnace door now to put the load inside the furnace. Our furnaces go up to 1800 degrees.
This is the heat treatment process.
The summers are very brutal. You go outside, sometimes it'll be 95 degrees out there, and our guys will go out to actually cool off.
Heat treating the engine component.
The ovens bake the crankshafts for up to 6 hours. They're now
almost 6 hours they are heat treating the component.
And we count on it lasting for a very long time.
Workers that assemble
They're assembling the components,
separate components
in the assembly area.
The end result is a rugged single-cylinder workhorse with a better power-to-weight ratio.
Single-cylinder engine is being used in this cutter.
With this much power, a chainsaw can
I think we will stop with this. Possible we will continue it in our next class. Okay. Shall we conclude the session?
Yes, sir.
Okay, thank you.
Yes, sir.
I will post the slides today. I'll post the slides today. Okay. Okay, thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.